All right, so this video is going to be on arithmetic sequences. So basically, arithmetic sequences by definition, again, is going to be a list of numbers that form a pattern of repeated addition or subtraction by a common difference. So essentially what we're looking at here is we're looking at like the beginnings of you recognizing like an algebraic kind of function, right? What are functions? Like what are these things? What do they look like in patterns? What do they look like in numbers? So that's kind of where the creation's going here. So we've studied basically what functions are, what their basic premises, and now we're going to start looking at like, okay, here's some data that's given to me. Like, what do I do with this data? How can I create this data? And one of the biggest things you need to know in linear algebra, okay, is this idea of arithmetic sequences. So an arithmetic sequence is when a list of numbers forms a pattern of repeated addition or subtraction by what is called a common difference. Now, a common difference, right? So we use a new word in the definition. So what is a common difference? And a common difference is simply the number that is used repeatedly, right, in your pattern. So the best way to kind of look at this is to kind of, here's a set of numbers. Let's identify, first off, if it's even an arithmetic sequence in the first place. And then from there, we'll decide, well, what's the common difference, right? So basically, you've got to get your adding and subtracting helmets on here, okay? So the first one here we take a look at is going to be this number 1. And number 1 says, okay, 1, 5, 9, 13. So basically, you're asking yourself, well, what's the difference between 1 and 5? Well, it's 4. What's the difference between 5 to 9? Well, it's plus 4. Well, what's the difference between from 9 to 13? And it's plus 4. So notice, to get from the next number, so our starting number is here, to get to the second number is add 4. Then I add 4 to 5, and I get 9, add 4 to 9, and I end up with 13. And essentially what you have here, okay, is the answer. Now, one of the things I didn't put in the definition of common difference is that the last thing here is I've got to add in here just what it's commonly a variable. So its variable is D. Okay, so essentially what we'll use to represent a common difference will be the variable D, and that's going to come from the formula in a minute or two that I'll show you. So anyhow, what we would do is we would just write, hey, the difference, so D for difference, equals 4. Now, we don't have to write the plus here, right, because it's positive. That's okay. Let's take a look at number 2. Okay, so number 2 is yes or no. So it goes from 1 to 3 is plus 2. From 3 to 5 is plus 2. And from 5 to 8 is plus 3. So the answer to this one is, well, we don't have a common difference. Common difference is it always has to be the same number. So the fact that it goes from plus 2 and switches over to plus 3 would make this a not arithmetic, right? So the answer to the question was no. Number 3, so 8 to 6 is minus 2, 6 to 4 is minus 2, and 4 to 2 is minus 2. So notice I am just subtracting 2 each time, and if I wanted to continue this pattern, I would subtract 2 from 2 and get 0, and then just continue to subtract 2. So the common difference here is negative 2, right? So if you have a subtraction, you do have to identify that it is negative, okay? You can't just write the difference as 2. You do have to identify the negative there, right? Take a look at number 4. So from negative 5 to negative 8, okay, that is minus 3. From negative 8 to negative 11, that is minus 3. And from negative 11 to negative 14, that as well is minus 3. So the common difference here is negative 3, right? Pretty self-explanatory stuff. Number 5, right? So from 5 to 10 is plus 5. And from 10 to 20 is plus 10. And from 20 to 40 is plus 20, right? So this one I want to take a look at is that some people may look at it, well, it's just multiplying by 2. And what I want to point out to you is that an arithmetic sequence is created through addition or subtraction. So I don't want you to be thinking about multiplication as a pattern or division as a pattern at this time. That's actually something you'll study in Algebra 2. But for right now, we're thinking about just addition and subtraction. So the answer to this one is no, it's not arithmetic, okay? All right, on number 6, 7 to 6 is -1, 6 to 5 is -1, 5 to 4 is -1, so we would say the common difference is -1, okay? Now, the next thing you'll have to do is just continue a pattern, right? So recognize a pattern, and the question is can you continue to add and subtract to a number over and over again? So let's just talk about continuing arithmetic sequences. So from 9 to 13, okay, is +4. 13 to 17 is +4. And then obviously, so the common difference is +4. So what I'm just going to do is keep adding 4. So 21 plus 4 is 25. 25 plus 4 is 29. And 29 plus 4 is 33. Okay, so I'm not going to do much more than that. I hope you get the idea there. We're just literally just completing it to fill in the blanks. What I do want to get at, though, is the arithmetic sequence formula. Okay, and the arithmetic sequence formula, okay, is the following formula. So it's going to be A, and it's going to have a subscript of an N, is going to be equal to D, which is the common difference, times this N minus 1. And then we're going to do this plus A sub 1, okay? Now, what A sub N means, okay, is it's going to mean the number in an arithmetic sequence, okay? So A sub N just stands for any number in an arithmetic sequence. The N is the nth term of an arithmetic sequence. Well, the nth term is just a variable because if you're in a sequence, you can talk about it being any placement in there, okay? So what you need to remember is, one, you're going to have to remember this formula, right? This formula is not going to be given to you. You're just going to have to memorize it for this test and for future uses. What you do need to know, right, is that D is the common difference, okay? And that this A sub 1, okay, is going to be the first number, okay, the first term. All right, so the first number in a list is called a term, or the first, any number in a list is called a term, so the first term. So if we take a look at number 10, right, so what it has here is these questions, right? It says, write the rule for the nth term, then find A sub 19, okay? So basically what A sub 19 means is it's another way of showing this idea of substitution, right? So A sub 19 means that N equals 19, right? So if N equals 19, then we can do substitution, right? I hope that makes sense to you very quickly what I'm talking about, because the formula is A sub N, and if it says then find A sub 19, okay, then that means N equals 19, and then you can do substitution. But the first thing I have to do here in this problem is write a rule. And remember, we talked about a rule, which means write an equation for the nth term, then find A sub 19. So the formula, or our equation, goes like this. A sub N is equal to D, known as the common difference. So what I have to find here is what is the value of D. And the value of D from 7 to 13 and 13 to 19, these are all plus 6. So I would write 6 parenthesis N minus 1. And then I would say let's add to that A sub 1. And A sub 1 is the first term, which was a 7. Okay, so 7 was the first number in the list. So then from here, I have my equation. Okay, so my equation is now done. And from here, what I can do is find A sub 19. So A sub 19 is literally just doing substitution. So from this problem, okay, we're going to write N equals 19, okay? That's the idea. It gets me to do substitution. So wherever I see an N, I can replace it with 19. So this equals 6 times 19 minus 1 plus 7. And now by doing parentheses first, right, I'm going to do the operations in here, right? I'm not going to do distributive property here. So I get 6 times 18, and I'm going to add 7 to that. And now 6 times 18 is 60 plus 48, so that's 108. So we get 108 plus 7, and I will get that my final answer for A sub 19 equals 115. So what does this mean? Okay, well, the 19th term, okay, the 19th number in this list would be 115. And that's what that means. So we use the formula to get there quicker. All right, so let's do another one really quickly here. So number 11, it has the same instructions here. Write a rule for the nth term, then find a sub 19. So here we go. So the first things first we do in this problem is recognize, well, what is the common difference? So from 30 to 26 and 26 to 22 and 22 to 18, these are all subtracting 4. So now I can go into my formula. So a sub n is equal to negative 4 times n minus 1, and it is always n minus 1, right? We wrote that in the formula. And then it says plus a sub 1. And now remember, a sub 1 represents the first number in the list, so that's 30. So from there, I have my equation. And then from here, what I can do is I can plug it in. So here we go. So a sub 19 means substitution. So n equals 19. So wherever I see an n, replace it with 19 minus 1. And I get plus 30. And then from here, I get a sub 19 is equal to negative 4 times 18 plus 30. And negative 4 times 8 is, was that 40 and 32, so negative 72. So this is negative 72 plus 30. So my final answer to a sub 19 is equal to negative 42. So again, what does this mean? It means that if I went out to the 19th number in the list above, okay, that I would get an answer of negative 42. And that's it. So that's arithmetic sequences. There's nothing more to it than that. Yeah, that's it. So basically, this work, right? You've got some extra problems you can practice up here, just plugging into the formula. There are some applications. The applications really aren't that crazy different. They're going to give you numbers to use, and you just got to find the arithmetic sequence based upon doing the same exact thing. But all they're going to do, as opposed to number 12, 15 of giving you the actual numbers, all they're going to do is create a little story. And what you're going to do is write out the numbers in a list, and then from there, do this formula. Okay? All right, so I hope that helps, but that's the end of our chapter for this one. So what I would say to you is go ahead, look at your review after you're done doing these practice problems. Make sure you do the homeworks, and that's it. So if you have any questions, please let me know.